Hi everyone. As we were doing the past papers of kinematics and dynamics of A-level physics, AS physics, physics 9702, and we were in the last part of the last question, second last question actually. This is the question of May-June 2024, paper 2, variant 2. So here it is given a skydiver jumps from an aircraft at time 0 and falls vertically downwards. The variation with time of her velocity v is shown in figure 2.1. Using figure 2.1, state the terminal velocity of the skydiver. It's a velocity time graph, and terminal velocity is the constant velocity when the downward weight and upward air resistance balance each other. The object falls or the skydiver falls with a constant velocity. This topic was also there in the O levels. So here we will see the point where is the velocity constant, and this is the point I have got here. And this is, we can easily observe, it is 39. So one mark part, it is 39 meters per second. By drawing a suitable line on graph on figure 2.1, determine the acceleration of the skydiver at time 9.0 second. So it's a speed or velocity time graph. And we know in order to find the acceleration, we need to find the gradient because the gradient of velocity time graph gives us acceleration. So the time they have asked for is 9.0 seconds. So I have to find the point of 9, 6, 7, 8, 9. So this is 9 here. But for gradient, we need 2 points. So for these type of questions, what we do here, we draw a tangent. So you have to use a scale for tangent. Obviously, I'm drawing roughly. Okay, this is my tangent here, and I am using 2 points. One is this point, and one this point. So this is basically at 19, 18, 18, comma 45, and this point is at 1.5, comma 27. So these are the 2 points. So for the gradient, y2 minus y1 over x2 minus x1, 45 minus 27. And here it will be 18 minus 1.5. So what I'm getting here is, why isn't it working? Okay, 45 minus 27 divided by 18 minus 1.5, and it is giving me 1.09. Okay, so 1.09 will be equal to 1.1, which is the correct answer. Now, the mass of the skydiver and her equipment is 68 kilogram. The upthrust on the skydiver is negligible. After reaching terminal velocity, the skydiver opens her parachute at time t1 A total drag force of 1800 Newton acts on the skydiver. Determine the magnitude and direction of the acceleration of the skydiver at time t1. Okay, so again, no upthrust, it means only weight, which is acting downward, and air resistance, which is acting upward. These two forces are present, and weight can be found out by using W is equals to mg. And after reaching terminal velocity, the skydiver opens her parachute at time 1. The total drag force of 1800 Newton acts on the skydiver. So for this thing, drag force or air resistance, both are same here. The first weight is W is equals to mg. Mass is 68, G is 9.81. I'm getting 60 into 9.81, which is 588.6. 588.6. So this is the weight that I'm getting. Now, the drag force is this. As the motion is downward, the weight is acting downward W, and the drag force is acting in upward direction. And since the motion is down, we know in order to find the resultant force, we subtract the force which is smaller from the greater one. Like it is going downward, we know that the weight is greater. What we are assuming here, basically. So weight is 588.6. What I said that we are assuming here that weight is greater because normally it happens till the object reaches the terminal velocity. As we know it, the skydiver has opened her parachute. So obviously the drag force will be greater. But according to the theory that we follow, that we subtract the force, one force from the force in which direction the object is moving. So right now, object is the skydiver is moving downward. So we are subtracting upward force from the downward force. So 588.6 minus 1800, what I will get here will be 1211.4 negative. And in order to find the what negative sign is telling me, it is obvious that 1800 is greater than 588. So the resultant force is acting in upward direction. If the resultant force is acting in upward direction, obviously the acceleration will also be in upward direction. So direction is here, which is upward, and force is equals to ma. So for acceleration, we have to divide 1211.4 divided by mass, which is 68 kilograms, divided by 68, I'm getting 17.81 minus 17.81. So I can write 18. So let me recheck. I'm getting 17.8, should be 17. 68 into 9.81 gives us 667. Okay, I made a mistake here. It was 667.08. So these type of mistakes, usually students make these type of mistakes. The calculation error. Everything was right, but putting the values wrong in the calculator, giving the wrong answer. Minus 1132.92. 1132.92. And the answer will be now changed by dividing it 68, 16.66. So 16.66 gives us 17. So this will be 17 meters per second. I hope it's clear. What they are saying, the parachute is fully opened at time t2. At a later time t3, the skydiver reaches a constant velocity of 5.7. Like we know, initially the terminal velocity was 39, but after reaching 39, the paratrooper, the skydiver, basically opens up the parachute. Due to this, due to the larger surface area of the parachute, the air resistance increases, the drag force increases, which decelerates it, the skydiver. But what they are asking, after all this is going to happen, the skydiver is again going to get achieve terminal velocity. But this time, the terminal velocity is less, which is 5.7. So if it is 5.7, it means initially it was 39, now it is very less. So what they are asking, the parachute is fully open at time 2. At a later time t3, the skydiver reaches a constant velocity of 5.7. Describe and explain the variation with time of the magnitude of our acceleration between time t is equals to 2 and t is equals to 3. Variation with time of the magnitude of our acceleration. At time 2, the parachute was fully open. Later time 3, the object again reaching the terminal velocity. What is happening with the acceleration, they are asking. We know because the resultant force that we have calculated, it was negative, and the negative acceleration shows us the deceleration. It means the speed of the skydiver is decreasing. If the speed um, is decreasing, it means the air resistance also decreasing, because is air resistance drag force increases with the increase in speed. If the speed is decreasing, it means the drag force is also decreasing. If the drag force is decreasing, it means a less number will be subtracted from the weight. Okay, so here what I'm going to write here, as the speed decreases, drag force acting on a skydiver also decreases. If the drag force is decreasing, it is decreasing the resultant force as well. If the resultant force is decreasing, the acceleration will also decrease. And again, the object will reach the constant velocity when acceleration becomes zero. So acting on the skydiver also decreases, which decreases the resultant force acceleration also decreases to zero, because force is directly proportional to acceleration. Again, I'm telling you, remember, initially, if we see the formula resultant force, it was weight minus drag force. So if initially the drag force was greater, we were getting a greater resultant force, but 667.08 minus 1800. But if this is not 1800, if this is, let's say, 1000, so we will get only 400 something or 300 and something. What is it telling us? Obviously, initially the resultant force was 1132, but now if the resultant force, if the drag force is only 1000, for example, it is only 1000, so 667.08 minus 1000 will give me minus 300 or 400 around. So resultant force is decreased. Force and acceleration are directly proportional. If resultant force is decreased, then the acceleration will also decrease. And then the skydiver will again reach the terminal velocity, acceleration becomes zero. Calculate the change in momentum of the skydiver between time 1 and time 3. Okay, at time 1, at time 1, after reaching terminal, the skydiver opens her parachute. So when the parachute is opened, at that particular instant, the speed was 39 meters per second. We initially mentioned it here. Now, at time 3, the velocity is 5.7 meter per second. So from 39, it is coming to 5.7. So what they are asking you to calculate? The change in momentum. So what is the formula to change in momentum? Is mass into change in velocity. Change in momentum is equals to mass into change in velocity. Mass is 68. Change in velocity. Final velocity is 5.7 minus. Why I'm using larger bracket. It is 39. And if I multiply both, 68 multiply by 5.7 minus 39, it is 2264.4. 2264.4. So 2300 would be the right answer here, negative. So this is the change in momentum. I hope it's clear. Now this is the question from May-June 2024, paper 2, variant 3. And this is question number 2 in that paper. Define displacement from a point. So displacement, we know it is the shortest distance between 2 points in a straight line. So from a point, we can have shortest distance from a point in a straight line in a particular direction, because displacement is a vector quantity. Okay, an object is projected horizontally at a speed of 6.0 meter per second from a slope as shown in figure 2.1. Okay, this is the direction. The slope is at an angle of theta to the horizontal. Air resistance is negligible. The object lands on the slope a time of 0.71 second later. The object lands on the slope a time 0.71 second later and stops without rolling or bouncing. Determine the horizontal distance traveled by the object. So they have given the time, they have given the horizontal speed as well. So speed is equals to distance upon time, or S is equals to Vt. V is it was 6.0 and time is 0.71. So if you multiply 4.26, so I'm getting 4.26, which will be 4.3 meters. Now determine the vertical distance traveled by the object. You know, if it is thrown in this particular direction, it will not go straight because the gravitational force is also acting on it. So when it is going in its direction, basically it will go like this. So it is going to cover some vertical distance. If you have studied the topic projectile motion, you know that for the horizontal motion, the object covers the distance at a particular speed because there is no air resistance and other else force in the horizontal plane. But in the vertical plane, there is gravitational force, and because there is no air resistance, so the acceleration due to gravity is 9.81 here. uh, it means that we can use equations of motion because no air means no other force than gravity. So we can use equations of motion because gravity is constant here, 9.81. For constant acceleration, we have equations of motion. So for the vertical distance, we have to use equations of motion. Initially, we can see here that at the time they are throwing it, uh, they have thrown it in horizontal direction, so initial vertical velocity is zero. So in vertical plane, initial velocity is zero. Vertical distance is required. Time is already given, which is 0.71 seconds. Acceleration we know, free fall 9.81 meter per second square. So what we are going to do, we are going to use the equation of motion that is suitable for this particular data. So S is equals to ut plus half at square. S vertical, u is 0, t is 0.71 plus half 9.81, 0.71 square. 9.81 divided by 2 into 0.71 square. So it's 2.47. So the vertical distance is 2.473. So I can write 2.5 here. So the vertical distance which the ball is covering is 2.5. Hope it is clear. If it is not clear, you can mention in the comment. I will try to explain it in some other video or in the comment as well if it is possible there. Use your answers in B part 1 and part 2 to calculate theta. Okay, it is not uh, that difficult. Basically, you have to use maths here. The vertical distance that you have calculated, it's SV, and the horizontal distance here, SH. It's a right angle triangle. And for this right angle triangle, we can easily calculate theta because we know the both sides adjacent and opposite. So it is easy by using the function of tangent. Tan theta here will be SV over SH. Vertical component is 2.473 and the horizontal component was 4.26. If we use both of them to find theta, 2.473 divided by 4.26 and the tangent inverse, and I'm getting 30.14. So here the theta is 30.14 in, so I can write 30 degree. So quite easy, 30 degree. Determine the magnitude of the displacement of the object from its original position. So the displacement from original position will be basically this hypotenuse. So if they're asking to calculate hypotenuse, we can easily find it by using Pythagoras theorem. So displacement square root 2.473 square plus 4.26 square in the square root. 2.473 square plus 4.26 square in the square root 4.93. So I'm getting 4.93, which means my answer should be 4.9. This question is very easy. By considering energy, calculate the speed of the object just before it lands. They are asking you to calculate the speed just before it lands by considering the energy. This is not the part of kinematics and dynamics, but we have to solve it if it is here. Law of conservation of energy, that energy converts from one form into another because there is no air resistance. That means all the potential energy at particular height the object has, it will be going to convert into the kinetic energy. So loss in potential energy is equals to gain in kinetic energy. That you have to remember one thing. And when it was in at particular height, it has initial velocity of 6. So it is going with initial velocity of 6. So at that particular height, it has both kinetic energy and potential energy. As it goes down, the horizontal velocity will not change. So there will be no loss in that kinetic energy, but there will be a gain in kinetic energy because it is going downward, it is gaining vertical velocity. So what we are supposed to do here, that initial first we have to calculate initial kinetic energy. Initial kinetic energy will be half mass. Do we know the mass? Okay, so we do not know the mass. So we cannot directly, we have to use ma m, and then it will be get cancelled out. Half m 6 square. 6 6 is 36 and divide by 2, 18 m. Initial kinetic energy is 18 m. Final kinetic energy will be half m v square. We don't know m. And the potential energy, the gravitational potential energy will be m g h. Height, the vertical distance, and we know that vertical distance is 2.47. It will be, if I form the equation, energy initial, at initial point it has kinetic energy and potential energy. At final point, that potential energy will be converted into the kinetic energy as well. So the equation will be initial kinetic energy plus loss in gravitational potential energy will give me final kinetic energy. So initial kinetic energy is 18 m. Loss in gravitational potential energy will be m into 9.81 into 2.47 is equals to half mv square. If I take m common, m will be cancelled out, and here it will become 9.81 into 2.47 plus 18. I'm getting 42.231. 42.231 is equals to v square over 2. If I multiply it by 2 and square root it, I'm getting 9.19. 9.19 means 9.2. So I'm getting 9.2 meters per second. Quite easy question. So basically, this was it. These are all the questions from kinematics and dynamics which came in May, June 2024.